Thank you, first of all, for joining my presentation. If you have any questions at any given time, feel free to interrupt me and ask the question, and I'll be happy to clarify any questions, any comments you may have. We all know about global warming, about how human activities contribute to a continuous temperature increase in every place around the world. We all hear about the ice melting, about the rising sea levels, about extreme weather conditions like floods and hurricanes. What can we do as software engineers to help prevent climate change? Are there any actions that we can take to build software that is friendly to the environment? Stay with me to find out how you can make a real impact in your work by building sustainable software. My name is Ioannis Kolaxis. I am a software architect and I work for Atos in Athens, Greece. I love learning about new technologies, trying to come up with innovative ways of how we can use them in order to solve real-world problems. Last year, I was awarded the first prize at Atos Innovation Week, our internal conference, for coming up with the most innovative idea. I am an inventor. I have filed several patents. And if you wish to become an inventor yourself, then you should visit my blog to read the article on how you can do this. I have been building software professionally for most of my career, having previously worked for IBM and Siemens. I am a speaker, and although nowadays I don't get the chance to speak in physical conferences, you know why. I previously had the opportunity to speak in many conferences, including Oracle Code One in San Francisco, USA, back in 2019. If you're interested in building sustainable software, then follow me on Twitter. First, I'd like to make sure that we all have a common understanding of the problem. What causes climate change? Human activities, like burning fuels, produce carbon dioxide and other gases known as greenhouse gases. These gases are present in Earth's atmosphere and they trap heat. They let the sunlight pass through the atmosphere, but they prevent the heat that the sunlight brings from leaving the atmosphere. They can be thought of as a blanket wrapped around the Earth. To prevent climate change, we clearly need to reduce the emissions of greenhouse gases. For simplicity, we will be referring to greenhouse gas emissions as carbon emissions. So who are the key contributors to carbon emissions? According to the International Energy Agency, electricity and heat producers are the top contributors by accounting for 42% of the global carbon emissions in 2018. Can you guess how this relates to our work as software engineers? As software engineers, we build applications that run on servers, which consume electricity. These servers are hosted in data centers. Our users, our clients rely on a network, most commonly the internet, to access our applications and exchange data. According to the International Energy Agency, approximately 2% of the global electricity is consumed by data centers and data networks, with the data networks consuming more electricity than data centers. Clearly, these data tell us that we need to make our software applications more energy efficient so that they consume less electricity and therefore emit less carbon. We all use applications like Google Maps to calculate the best route from point A to point B. The best route to our destination may be one with the shortest distance or the fastest one. Nowadays, Google Maps allow us to calculate the most fuel-efficient route, which takes into account several factors, including traffic jam. What happens when we need to move data from point A to point B over a data network? To reduce the electricity consumed by data networks, we need to minimize the distance covered by our data when traveling over the network. That is, we need to reduce the number of hops from point A to point B, like we do with Google Maps. To achieve this, we need to have our servers located right next to our customers. So for example, if we have customers in Europe, then our servers must also be located in Europe. We don't want our data to travel around the world. It's even more efficient when we don't transfer our data, but instead process them at their source, at the edge, as we call it. So don't transfer your data if you don't need to. Besides minimizing the distance traveled by data, we also need to minimize the size of the data sent over the network. We can do this by filtering out any data that may not be necessary and always compressing our data before sending it over the network. Remember, energy-efficient applications do not send their data traveling around the world. When choosing the location that will host your software applications, make sure that this is close to your end users. What other factors should you consider when choosing the location of the data center that will host your application? We just mentioned proximity to end users. Some locations consume electricity that comes exclusively from burning oil or coal, both of them producing high carbon emissions. Other locations may consume green electricity that comes from the sun or the wind, therefore having zero carbon emissions. Google Cloud provides data about the mix of carbon-based and carbon-free electricity in each region, enabling us to choose the greenest areas, the greenest locations for our applications. Even if the end users of your applications are not located near one of these green locations, then you could consider running your batch jobs on the cleanest region, on the cleanest option. We explained how choosing the right location for data centers can help us consume greener electricity. How can we reduce the amount of electricity consumed overall by data centers? Here's a diagram of a data center showing the applications that are being hosted on these servers. This may look like your data center, your own data center, either on premises or on the cloud. Did you know that up to 50% of the servers in your data centers, they waste energy? Most of the time, they are idle and they just waste energy. These are redundant servers in standby mode that just wait for a failure to happen so that they can take over and handle customer requests. But in the meanwhile, 50% of your servers just wait. They consume electricity and consume energy. Let's take a closer look. When failures happen to our applications, for example, a hardware fault in a server, we don't want our end users to notice this failure, but rather wish to continue doing business as usual. For this reason, we usually have one or more redundant servers that are in a standby mode, doing nothing other than waiting for a failure to occur to the active servers so that they can take over and handle all the subsequent requests. As displayed in this diagram, upon failure of server A, a failover is performed to the previously idle server, which assumes responsibility to fulfill new user requests. Speaking of redundant servers, this is a car that features two engines for redundancy. It has one engine in the front of the car and an identical engine in the rear of the car. It even has two separate petrol tanks, again for redundancy. It was designed specifically for safari trips to Desert Sahara, where a failure in your engine could be fatal. If you plan to go for a trip to Sahara, then you should definitely choose a car with redundant engines. But when you go to the cloud, your applications don't need to have redundant servers. Can you think of an alternative high availability model for your applications that does not use redundant servers? With the advent of cloud and containers, Docker ones or alike, we can enable a high availability model for our applications that does not use redundant servers. One of the main characteristics of containers is that they have a size in the range of several megabytes, which is orders of magnitude smaller than virtual machines, which have a size in the range of several gigabytes. Similarly, lightweight containers have a startup time of several seconds, which is again smaller compared to virtual machines, which have a startup time of a few minutes. The established practice of using redundant servers is due to the time that it takes to spin up a new server instance, that is, a new virtual machine, when a failure occurs to the active server. If users had to wait for several minutes for a new virtual machine to start, then the failure would be noticeable. But if this application were containerized, then a new container instance could be started in a fraction of time, therefore allowing for a seamless failover without the end users being able to notice this failure. As shown in this diagram, by containerizing your application, you can adopt a new high availability model that does not use any redundant servers. As soon as there is a failure in a container instance of your application, you can quickly spin up a new container instance. Moreover, public cloud providers enable us to run these containers without having to worry about the underlying infrastructure, without having, for example, to provision or maintain any virtual machines for these containers to run on. Concluding, by containerizing your applications and running them on public cloud providers, you can adopt a new high availability model that reduces the resources consumed by your applications, therefore reducing both the cloud bills and the environmental footprint of your applications. And remember, when you go to the desert for a safari trip, always choose a car with redundant engines. But when you go to the cloud, you don't need any redundant servers. Speaking of cars, modern cars are equipped with a stop-start system that stops the engine when it's not needed. When you're stuck in a traffic jam or when you wait in front of a red traffic light, the stop-start will stop the engine so that the fuel consumption is reduced, and therefore the carbon emissions are reduced. Older cars did not have this system, which meant that the engines would keep on working even when they were not needed, when they were idle. Can you think of a similar example for software applications? Can you think of a case where software applications do not serve any requests, but they just wait? And although they wait, they consume resources. They consume CPU, they consume RAM, they consume electricity. If you have applications that are idle most of their time, waiting for an event to happen so that they can start processing something related to this event, then this is a sign that you can have your applications re-architected to adopt the function as a service model, which works like a stop-start mechanism. Our goal here should be to minimize the idle time of our applications, therefore increasing the utilization of our compute resources. Applications that leverage function as a service are only executed in response to external requests or events. They run just for a short period of time until the event is processed, and next they are terminated if there are not any other requests pending. As displayed in the diagram, an application is broken into individual functions, with each one of these functions doing a single independent piece of work. Each function may be triggered by an event, such as an HTTP request, or a file uploaded to cloud storage, or a new event arriving in a queue, or it could be a task scheduled to run at a given time, like a cron job. Clearly, when adopting the function as a service model, our application does not run as a whole, but individual functions are executed instead. This means that by adopting this model, we transition from long-lived applications to short-lived functions. Function as a service falls under the category of serverless architectures, which means that software engineers can focus on writing applications without having to manage or provision any servers. The cloud provider takes care of all the underlying infrastructure, also handling automatically the scaling of our applications when, for example, there are multiple incoming HTTP requests. Likewise, the cloud provider takes care of scaling down to zero our functions when there are not any requests pending. All the public cloud providers allow us to run serverless functions. As an example, Microsoft Azure allows us to write functions in one of the programming languages shown here in this slide. We should be avoiding long-running functions as the default timeout is set to 5 minutes. It's worth mentioning Azure Container Instances, a service that allows us to run code written in any programming language as long as it is packaged in a container. It also supports long-running tasks that run for days or even weeks, therefore offering more flexibility compared to Azure functions. Please note that you should always adjust the default values of the CPU and RAM that are allocated to each container so that you can maximize the usage, maximize the efficiency of the resources that are being used. As we learned, modern cars have introduced a stop-start mechanism to make our cars more fuel efficient. You can do the same with your software applications by introducing a stop-start mechanism, that is, by leveraging function as a service. We had quite a few examples about cars so far. We know that we have different types of cars depending on the fuel that they consume. For example, some cars consume petrol, others consume diesel. Nowadays, we even have electric cars. Some of these cars are friendlier to the environment compared to others, depending on the fuel that they consume. What happens with software applications? Is there some kind of fuel for software applications? What could this be? The fuel for software applications are actually programming languages. Let's think of the different categories of programming languages that we have. We have compiled languages like C and C++. We have languages running on top of virtual machines like Java and C#. And we also have interpreted languages like JavaScript, Python, Perl, and Ruby. Some programming languages consume less energy than others. Can you guess which ones? According to academic research, compiled languages tend to be the fastest and most energy efficient ones. C, Rust, and C++ are the most energy efficient languages, whereas Ruby, Python, and Perl are the least energy efficient ones, with Perl consuming 80 times more energy than C. It's 80 times, 80. If your application uses one of the most energy efficient languages, then you're fine. But what happens if your application uses one of the least energy efficient languages like Ruby, Python, and Perl? Should you rewrite your application? As always, the answer is it depends. If your application is being used by many users, for example, internet scale applications, then you should identify one or more modules that consume the most energy and then make a decision. Do you need to rewrite one or more of these modules in an energy efficient language? It's up to you. Speaking of programming languages, Java is today one of the most popular languages for the development of enterprise applications. According to a survey conducted by JetBrains, Java ranks as the second primary language used by professional developers, with 72% of them still using Java version 8, although the latest release is Java 17 as of September 2021. Modern versions of Java have introduced several enhancements that reduce the memory footprint of our Java applications. Since Java 9, the memory allocation for string objects has been enhanced, consuming 50% less space for strings that are made up of Latin characters. According to tests, we can have performance improvements of up to 10% just by upgrading from Java 8 to Java 9. For more details, you can read an article I've written on my blog about this topic. Likewise, since Java 10, Java applications running on the same host can take advantage of class data sharing, a new feature that helps reduce the memory footprint of up to 15%. This feature is especially useful for microservices that are built on the same Java stack. Again, for more information, you can refer to my blog. Nowadays, there are several distributions of Java available, such as Azure Zulu, Eclipse Adoption, and IBM Semeru. One difference that is often overlooked is the Java virtual machine that these distributions of Java rely on. Most distributions, such as Eclipse Adoption, rely on Hotspot. This is the virtual machine that has always been released together with Oracle's JDK, and it is the most widely used one today. IBM's distribution is based on Eclipse OpenJ9, which claims to have a lower memory footprint and a faster startup time. According to some experiments that I have run with a well-known Java application, Spring Pet Clinic, as you can see them here in this diagram, OpenJ9 indeed has a lower memory footprint. Clearly, running your Java applications on Eclipse OpenJ9 can have a lower impact on the environment, given that less resources are consumed, while at the same time, it can also help you cut down on your cloud costs. To make your Java applications more energy efficient, you need to upgrade to the latest version of Java, Java 17, which is also a long-term support language. And additionally, it is worth considering migrating to a lightweight Java virtual machine like OpenJ9. When running applications on cloud, we're being charged based on the resources consumed by our applications. The more network traffic that we consume, the more we pay. The more the CPU and RAM used by our applications, again, the more we will pay. As a rule of thumb, reducing the cloud bills of our applications implies that we are making our applications more energy efficient, since they are consuming less resources. Especially if you run your applications on Microsoft Azure. Azure Well Architected is a framework of best practices that assesses your application against several criteria, including cost. By following most of these recommendations, you will essentially reduce the resource consumption of your applications, therefore reducing their carbon emissions. And as you can see, higher score means you've done a better job at reducing and controlling the costs of your applications. So let's summarize all the actions that you can take to make your software applications more sustainable. First of all, especially for Java applications, you need to upgrade to the latest version of Java, Java 17. Additionally, you can migrate to a lightweight Java virtual machine like OpenJ9. Next, remember the data that you transfer over the network. You need to choose the shortest distance and always compress your data to minimize their size. Next, you need to get rid of redundant servers. You don't need redundant servers on the cloud. Remember the stop-start mechanism that cars have adopted? You can do the same with your software applications by transforming long-lived applications to short-lived functions. And the last action item is to identify energy-consuming components in your application and rewrite them in a new language that is more energy efficient. Clearly, this is the last step and requires the most effort, the most investment from your side, having to rewrite everything in a new language. Here, the overarching theme is reducing the cost of running your applications on cloud. By doing this, you are likely making your applications more sustainable, more friendly to the environment. Now it's up to you. It's your turn. What actions will you take to help prevent climate change? Please scan this QR code and tweet your answer. And you can also unmute yourself and ask any questions you have about the presentation. You can also type your comments or questions in the chat. Any questions? Okay, there is a question. If we have considered reducing energy consumption by using dark mode on OLED screens. Yeah, actually, yeah, this is an option, you know, whenever we have presentations like this one to display everything in a dark mode. As a matter of fact, the template that we have, the PowerPoint template in Atos has changed from white to black to make all our presentations friendly to the environment. So this is also an option. Okay, there is a question if we have actual figures on using dark screens. No, I don't have any figures on that. Okay, we have a new question. If it does it really do that much if the LED is not shut off completely? I'm not sure if I have an answer to that. The presentation was mostly focused on reducing the impact, reducing the environmental footprint of software applications. So there are definitely many things we can do for the hardware as well, such as the screens that you just mentioned. Any other questions specifically about software applications? How big is the percentage of power consumption of all clients compared to the servers? If you remember from my presentation, according to the International Energy Agency, 2% of the global electricity is being consumed by data centers and data networks. Having searched on the International Energy Agency, I couldn't find any official data about the consumption of clients, but there are some studies that say it's another 2%, an additional 2%. And as more and more people are using laptops, tablets, mobile phones, this is increasing. This is continuously increasing. So a rough figure would be that 2% for the servers and data networks, and another 2% for the clients. Okay, there is another comment that one could for sure rewrite to an energy-saving app, but wouldn't produce that much more than saving. Last year at the Amazon Web Services reInvent, there was a really nice presentation of how they had rewritten a part of the serverless functions using Rust. And this was the argument that, Amazon Web Services operates at large scale. It has a million of users worldwide. So in their case, it made a difference. So that's why they chose to rewrite everything on Rust. Okay, there is a question regarding Azure well architected, if there is an equivalent for other platforms. Yeah, as far as I know, Amazon and Google have similar frameworks for their platforms that provide some best practices and guidance on how you can reduce the cost of your application. So it's essentially the same thing, no matter what your public cloud provider is. Always try to reduce the cost of your cloud bills. If you do this, you're likely also reducing the carbon emissions associated with your software applications. Yeah, there is another comment that it needs people, money, time, developers. Yeah, what I would like to stress is that, by participating in this presentation, you made the first step towards this direction. Next time that you take some decisions in your company, in your daily work, and you need to take some technical decisions, you will be in place to make better, to take better decisions, to judge better, knowing, for example, the differences in the programming languages and the impact that they have. So even if you don't go back and invest effort, invest time in rewriting everything, at least now you know which is the best option, which is the greenest option for writing a new software application. Yeah, and there is also a comment that we should never touch a running system. Yeah, if it ain't broke, don't fix it. We have more time for questions. If you have any questions, please drop them in the chat. There is a comment, I'm not sure I understand this one. I would switch things to use batch upload instead of applications. See Corona app. I don't understand what you mean by that.
I just hope it's okay. I switch on my mic to make it more clear.
Yes, yes, of course.
You can also see me in person if you like, but I'm wearing today a mainframe t-shirt. Don't be afraid. Okay, so I switch it off again. It makes more pleasure. Okay, what I mean, I watched the presentation today about the Corona app, and what they're doing is they're moving it under pressure to use standard applications, standard ways of working, and most of this Corona app was done with this application. Instead, what they do in the so-called health center in Germany, called them Gesundheitsamt, they're still working with the papers.
I see.
So that means, of course, you have a lot of applications in the past. In my office, there's an IBM i-series, which is quite nice as a heater for the winter, but they will never touch it because they have 100,000 lines of RPG code. But what they can do, they can migrate it to services and then offer other possibilities or link services together to make it more easier with artificial intelligence, as the new word is called today. They can combine the service more intelligent, so they don't rewrite the thing, just push the data into the database. Just as a comment, but great presentation, thanks. Gives me a lot of input.
Thank you. We have 5 more minutes until the break. So if you have any other questions, don't be shy. Is there something from the presentation that seems like easy to you to implement? There is a question from Oliver, if making efficient algorithms has any effect. Yeah, of course, you should. Yeah, there is always the possibility of improving the algorithms to make them more efficient. This academic research that compared the languages had a set of tests with different algorithms, all of them implemented in each language, and they compared the same algorithm in different languages. But of course, if you can come up with more efficient algorithms, then this always helps. And when talking about preventing climate change and reducing carbon emissions, there is one new field of digital transformation that we haven't talked about. So just think of an application like Zoom that we use for this conference. The advice I gave today, the hints I gave in my presentation, could apply to Zoom on how to rewrite it in a new programming language so that it consumes less energy. But there is also the aspect of digital transformation. Instead of riding our cars to go to the office every single day, more and more of us nowadays use Zoom to work remotely. There, the savings in carbon emissions from our cars are much bigger, and similar techniques, could be used in all the industries. The so-called digital transformation of changing how things work in the physical world by using technology. This is where the biggest potential lies in reducing energy consumption and reducing carbon emissions. But this is the topic of a completely different presentation. Yeah, there is a link that Rainer just shared. Thank you.
It's me again. I know one of the developers from Sweden. They are part of this project, but I don't know if they still do this. There you can see what really happens from all perspectives if you do something or not.
Okay, thank you for the link. It's myecocost.org. I'll check this out. Thank you again for joining and for all the questions you answered. If you still have any questions, feel free to reach out to me via Twitter or LinkedIn, and I'll be happy to connect with you and have a chat with you. So thank you, everyone. Bye.